Welcome students. It is the second lecture in which we will study the KVL and KCL. What is the KCL? It is the Kirchoff current law. What is the KVL? It is the Kirchoff voltage law. In lecture 1 we studied the active and passive element. We studied the active and passive elements, unilateral and bilateral elements, linear and non-linear element. Clear? As we discussed in lecture 1, discuss the active element which supply the energy to the network, passive element which consume the energy or store the energy. Clear? The example of active elements was the voltage source and current source, in which we discussed the practical voltage source, ideal voltage source, practical current source and ideal current source. Clear? Similarly, in unilateral and bilateral element, the examples are, for the unilateral it is the diode, the current conducts in only one direction, and the bilateral element, that is the R, L and C, and we conclude that in resistance the current is flow in both directions. And the linear and non-linear elements, linear is resistance and the non-linear elements, these are the diode, triode, transistor, these are the non-linear element. Clear? Now we will start the KCL. First of all we will discuss the KCL, that is the KCL. It is the abbreviated form and it is simply the Kirchoff's current law. Kirchoff's current law. Clear? Kirchoff current law. Here you will see, say this is a junction, this is the current I1, say this is the current I2, this is the current I3, this is the current I4, say this is the current I5 and this is the current I6. Clear? If it is the junction, you will see the I1, I2, I5, these are the incoming current. It are these current I1, I2 and I5. It is the junction and it is coming towards the junction. Clear? And the I6, I3, I4, these are going away from the junction. Clear? That means what are the incoming currents? I1, I2 and I5, these are incoming current. कैसी currents हैं? These are the incoming currents. Clear? The outgoing currents, that is equal to the I4, I3, I6. Clear? Now the Kirchoff law. What the Kirchoff law statement? That any junction, the incoming current is equal to the outgoing current. Now you will see what are the incoming currents? I1, I2 and I5. That means I1 plus I2 plus I5, that is equal to the I3 plus I4 plus I6. Clear? Or you can say that is the I1 plus I2 plus I5, that is minus I3 minus I4 minus I6, that is equal to 0. Clear? That means we see that when we say the I1 plus I2 plus I5 minus I3 minus I4 minus I6 is equal to 0, that means the algebraic sum of the incoming current and outgoing current is 0 at the junction. Clear? It is not the fundamental rule that the incoming current is always taken as positive. Clear? Suppose if we take the negative sign common, then what will be this? This is the minus I1, minus I2, minus I5 plus I3 plus I4 plus I6 is equal to 0. Clear? So basic rule is that the incoming current that is equal to the outgoing current. Clear? Now you will see incoming current is equal to outgoing current. Clear? Say this I1 that is equal to the 7 ampere, I2 say this is the 4 ampere, I5 say this is the 9 ampere, I6 clear, say this is the 3 ampere, I3 that is equal to the 2 ampere, and we have to find the value of the I4. Clear? Then what is the relation? Incoming current is equal to the outgoing current, that is the I1 plus I2 plus I5 that is equal to the I3 plus I4 plus I6. What is the value of the I1? 7. What is the value of the I2? 4. What is the value of the I5? 9. What is the value of the I3? Clear? That is the 2 plus I4. This is the I and this is the 3. Clear? And you will see 7, 4, 11, 11 plus 9, 20, 20 minus 5, and we are getting I that is equal to the 15 ampere. Clear? Sometimes the I is given in term of the charge, where the charge is the function of t. Clear? Then always remember, what is the I? It is equal to the dq by dt. We differentiate the q with respect of time when the q is the function of t. Clear? For example, the q that is equal to the t square plus 2t. Clear? Then what is the I? It is equal to the dq upon dt, that is equal to the 2t plus 2. At a particular time, if we have to find the value of the current, say t is equal to 1 second, that is the 1 into 2, 2 plus 2, that is equal to the 4 ampere. Clear? At the initial time, when the t is equal to 0, the current will be 2 ampere. Clear? One important thing is that the KCL, it is simply the conservation of charge. Clear? The KCL is based on conservation of charge. See this equation, that is the I1, clear, plus I2 plus I5 that is equal to the I3 plus I4 plus I6. If we multiply with the t both sides, then what is this? I1t plus I2t plus I5t that is equal to the I3t plus I4t plus I6t. Clear? And you know that what is the current? It is simply the rate of flow of charge. That means when I1 is multiplied with the t, that is the Q1 plus Q2 plus Q5 that is equal to the Q3 plus Q4 plus Q6. Clear? The incoming charge, that is the Q1 plus Q2 plus Q5. What is the outgoing charge? That is the Q3 plus Q4 plus Q6. Clear? That means the incoming charge is equal to the outgoing charge. Clear? Then always remember, the charge contained at the junction, it will be always 0. Clear? And this is KCL. It is also named as the point law. Clear? In objective type question, he said the KCL is based on energy, based on momentum, based on conservation of charge. Then what will be the correct answer? The KCL, it always based on the conservation of charge. Clear? Now we will discuss the KVL. Clear? It is very important, the KVL. Clear? The KVL, it is simply the Kirchoff voltage law. Clear? The KVL. KVL, it is the Kirchoff voltage law. KVL, it is the Kirchoff voltage law. Kirchoff's voltage law. Clear? Before starting the Kirchoff voltage law, see, suppose this is the point A and this is the point B. Clear? And we say this is the BA and this is the BB. Clear? If we say the BA is greater than BB. Clear? When the BA is greater than BB, that means the direction of the current, it will be the A to B. A to B. Clear? And if the BB is greater than BA, then the direction of the current will be B to A. Clear? Always remember, the current always flows from the high potential to low potential. Clear? As you see in heat, clear hota hai? The heat travels from high temperature to low temperature. Clear? If BA is equal to BB, if in any case when the BA is equal to BB, that means there is no voltage difference. When there is no voltage difference, that means there will be no current, or you can say the current will be zero. Current will be zero. Any doubt? Clear? The current, it will be zero. Clear? Now you will see what is the KVL. In fact, we are taking a small and easiest example, and we will take the complicated problems in our another lecture when we will solve these problems. But first of all, it is very important how to apply the KVL in mesh and loop. Clear? ध्यान से देखिए. For example, this is the source. This is the E1. Clear? This is the, these are the two resistances. Clear? This is the R1. Say, this is the E2. This is the resistance. Say, these are the R3 and R4. These are the R3 and this is R4. Clear? Say, this is the, it is like this. Clear? And it will be, say, this is the R1, this is the R1, this is the R2, and this is the E1. Clear? This is the E1. Clear? And say, this is the resistance R5. Clear? Now we have to identify what is the mesh and what is the loop. Clear? If we see, this is the A, this is the B. Clear? This is the C, this is the D, this is the E, and this is the F. Any doubt? Clear? Always remember, current flows from the negative to positive. Say, this is the I1. Clear? What is this? This is the I1, and say this is the I2. We are taking the I1 with the source E1 and the I2 with the source E2. Clear? You will see it is. What is this? This is a mesh. What is this? This is a mesh. Clear? The mesh, and if we will take the complete circuit, it will be a loop. Clear? Always remember, in mesh there is no internal loop. Clear? There is no common loop. It will be a single. Clear? So these are the meshes 1 and this is the 2. Clear? If we have to write the equations, please write. देखते हैं. In mesh, A, F, C, B, A. Clear? In mesh, always remember which is the starting point. In the last, the same point will occur in the circuit. Clear? That means in mesh. Clear? Now you will see what is this. This is the I1, this is the I2. Then what is this? this current is the I1 plus I2. Clear? Now we will see that what is the drop in this? What is the V? That is equal to IR. In the R1, the current flowing is I1 plus I2. That means I1 plus I2 into R1 plus I1 plus I2 into R2. और यहाँ पर करंट कितना है? What is the current? This is the I1. Clear? That is plus I1 R5. Clear? And it is equal to the E1. This is equal to the E1. Clear? That means negative to positive. It is the voltage rise, and here the voltage drop. Clear? The voltage rise, it must be equal to the voltage drops. Clear? And always it is a short point. Always remember, when the current is going from negative to positive, the voltage source is always taken as the positive. Clear? If the current is flowing like that, it is going from positive to negative, we will put the minus. Clear? Similarly, you can write the mesh equation for this. Clear? And it is the method to apply the KVL in the network. Clear? The KVL can be applied on the complete mesh also. Clear? That is the I2 R3 plus I2 R4 plus I1 R5, that is equal to the I1 negative to positive E1, and here negative to positive E2, that is the E1 plus E2. Clear? Now you will see, as the Kirchoff current law is based on the conservation of charge. Clear? Now similarly, the KVL, it is based on conservation of energy. Conservation of energy. Clear? It can be explained with a small circuit. Say this is the E. Clear? This is the resistance R1. This is the resistance R2, and say this resistance is R3. Any doubt? Clear? Say here the drop is E1, here the drop is E2, here the drop is E3. Clear? What is the E1? It is the voltage across the R1. What is the E2? It is the voltage across the R2. And the E3, it is the voltage across R3. Clear? You will see, what is the E? That is equal to the E1 plus E2 plus E3. Clear? The voltage is always distributed in the series circuit. Clear? Say the current is I. What is the current? This is the I. Clear? If we multiply the equation, it is the EI, that is equal to the E1I plus E2I plus E3 into I. Clear? Now again we will multiply both sides by that small t, time. Clear? That is the EI into t, that is equal to the E1 IT plus E2 IT plus E3 IT. Clear? EIT, that is equal to the E1 IT plus E2 IT plus E3 IT. Clear? Now you will see, what is the power? Power into time, that is equal to the energy. Clear? Then what is the EIT? It is the energy supplied. What is this? This is the energy supplied. Clear? And similarly, E1 IT, E2 IT, E3 IT, it is the energy consumed. What is this? This is the energy consumed. Clear? From this, we will see that when the energy supplied is equal to the energy consumed, that means it follows the law of conservation of energy. Clear? The KCL, it is based on the conservation of charge, and the KVL, it is based on the conservation of energy. Clear? Now you will see why we are studying the KCL and KVL in the network. Clear? You will see KCL, KVL and Ohm's law, these are the fundamental law. Clear? These are the fundamental law. Understand? Clear? Now the KVL and the KCL. Clear? The KVL, it is used in the mesh analysis. It is used in the mesh analysis. Clear? Where the KCL, it is used in the nodal analysis. It is used in the nodal analysis. Clear? The KVL, it is used on the mesh analysis. KCL, it is based on, it is used in the nodal analysis. In objective type question, he said the mesh analysis is based on. Clear? Nodal analysis is based on. Clear? Then what will be the correct answer? The mesh analysis, it is based on the Kirchoff voltage law, that is the KVL, and the nodal analysis, it is based on the KCL. Clear? You are so this is the basic of the KCL and KVL. Clear? In further, when we will study the network theorem, then we will see that why we are studying the KCL and KVL. Clear? Now what are the limitations of the KCL and KVL? What is the limitations? Clear? It is only valid for the lumped network. Clear? Lumped network. For example, this is the resistance. Clear? That means if we say this is of the 6 ohm, then it is called the lumped network. Clear? Any doubt? And the distributed network which are used in the transmission line, it will be like this. When we will say this is the distributed network. Clear? The lumped network, that means this is the value of the resistance having the value of 6 ohm. Any doubt? Clear? Now we will discuss for the mesh analysis, nodal analysis, there will be the 3 terms. Clear? First, that is the mesh. First is the mesh. Second, the node. Second is the node, and the third is the branch. Clear? Always remember, the mesh, it is given by the end, node, it is given by the end, and the branch, it is given by the B. Clear? Now we will find the relation between the mesh, branch and node. Mesh, branch and node. Clear? We will take example, the relation between the N and B, yani ki mesh, node and branch, it is simply the N is equal to B minus N plus 1. Clear? So what is the N? It is equal to the B minus N plus 1. We will take an example. For example, this is the 10 volt. This is the 10 volt. Say, this is the 1 ohm. Clear? This is the 4 ohm. This is 2 ohm. Clear? This is a voltage source. This is the resistance of 3 ohm. Clear? And this is the 1 ohm. Clear? Now you will see how many mesh and what is the mesh. This is the mesh 1. This is the mesh 1. This is the mesh 2 and this is the mesh 3. Clear? That means what is the N? That is equal to the 3. Any doubt? Clear? Now you will see, say this is the first node 1. Clear? What is this? This is the 2. Clear? What is this? This is the 3. Clear? What is this? This is the 4. Clear? What is this? This is the 5. Clear? Now, how many nodes are there? Clear? This is the 5. Clear? And that is equal to the 5. N is equal to 5. Please count. What are the number of branches? 1, 2, 3, 4, 5, 6 and 7. Clear? That means the B that is equal to the 7. Now if we select the mesh, select the node and select the branch, then we will confirm that it is fulfilling this m is equal to b minus n plus 1. Please put the value. What is the value of the b? 7. What is the n? What is the n? 5. 7 minus 5 plus 1. 7 minus 5, 2 plus 1, that is equal to the 3. Clear? So today we discuss the KCL, KVL, mesh, branch, node and the relation between the branch, node and mesh, that is the n is equal to b minus n plus 1. We also studied what is the difference between the mesh and loop. Clear? In the next lecture, we will discuss the mesh analysis and nodal analysis. How we are applying the KVL, KCL to solve the network with the help of mesh analysis and nodal analysis. Thank you. You studied when you studied the lecture 1 or the lecture 2. If you have any doubt, any problem, please comment on the comment box or mail on my mail ID skgoelmiet@gmail.com. Thank you.